Relative minimum is the low points of a function. It's where it continuously goes from decreasing to increasing. So notice that's opposite of relative max. The points just to the left are higher. Okay? As you guys are writing this down, let me just show you a little example here. Kind of like we were talking about before, what I just drew on the board. Let's say we had something like this. Okay? Again, it doesn't have to be completely curvy, but notice this point right here, all the points to the left and right are higher, so it's a relative minimum. Same thing for here. It's not the absolute lowest point, but every point around it is higher. And you could even say this is a relative minimum. It is the absolute minimum, but it's also relative because all the points around it are higher. And it continuously goes from decreasing to increasing. Okay, so any comments about that? Does anybody have another definition they want to share that helps them maybe, or are these three pretty good for you? Okay. So following is the function f of x. What are the relative extrema of f of x? So when it asks for the relative extrema, that covers both the min and the max. And when you write the answer down, you can just write relative min and relative max, rel min, rel max to be. You got to be careful about this one, guys, because remember, it's all the points. It's got to have points to the left and right of it. Okay. Right. The first point you might think is a relative max is that point. Can somebody explain why that's not a relative max?
Higher or lower than that one.
Right. There's no points to the right. Now, if the graph were to go like this, yes, you could say that that is a relative max. Okay? The next point you might think is this, but the points to the right of it are equal. So, and then obviously for the same reason that one's not. So this one has no relative max. For the same reason, it's not going to have any relative minimum either. If you go back and look at the graph, there are no points in the graph where it's smaller than the points around it. Okay? I normally, save the tricky one for last, but went ahead and showed you that one first. Just the point is, not every graph has to have a relative minimax. All right, let's look at this one. Does this one have a relative max? No. Now, you might look at this one, and you might think that's a relative max, but what's the problem with that? It's straight on the left. Good. Okay, and then I don't really see anything else on the graph. Okay, well, this one might be, but what's the problem with that one? It goes down on the right, but it doesn't go down on the left. It has to go down on both sides. Okay, but it does have a relative minimum. Where would that be? Zero, 1 right here. Every point to the left and right goes up. It's the bottom. So it does have a relative minimum at 0, 1. Okay, any questions on that? I don't think there's any other relative minimums. Nope, so that's pretty much it for that. All right, let's take a look at the next graph. You got to be careful on this one. Okay, somebody want to share where they see a relative minimax? Good, so we talked about the fact it doesn't have to be curvy for relative minimax. There can be a cusp there, as long as all the points to the left and right are smaller, which they are. Okay, every point to the left and right is smaller than that point. So we do have a relative maximum at 4, -6. Okay, are there any relative minimum? So that's a whole, right? So we cannot count that as a relative minimum. Good. At -6 and 2, every point to the left and right is bigger. So it's the bottom of the curve, -6, 2. There can be more than one. I think the next one is going to show us that. That's a good question. All right. No, this one does not address that issue. I'm sorry. Can you spot a relative min-or-max on this graph? No. So the issue is we just have a bunch of endpoints, right? There are no points where it's the tallest around it, and there are no points where it's the shortest around it. So there really isn't even a point on here that's a question. Maybe you might think this is a relative minimum, but there's no points to the right of it. Okay? So no relative maximum and no relative minimum. Okay. This is the one that has multiple. All right, so somebody raise their hand and tell me a point that you think is a relative min-or-max. Yes.
-2, 0.
-2, 0. Okay, is that a relative min-or-max? Okay, good, because all the points around it are smaller. All right, next point. Yes. Perfect. What is that? Yep. Good job. And I think there's 2 more. Next up. 1 and -2. Okay. What is that? We got one more point. Zero, -3. Yep. Min or max? Okay, you got it. So we got relative maximums at -2, 0, and 1, -2. And we have relative minimums at -3, -1, and 0, -3. Last point I want to make. As you can see, at times a relative maximum is below a relative minimum. And let me explain that one. This relative maximum is below this relative minimum. See, it really doesn't matter, does it? It's all relative. Okay? And yeah, that's why we use the word relative, because it depends on the points around it. So you're going to take the same worksheet and you're going to answer the questions on what's relative minimum, what's relative max.